All right, ladies and gentlemen, this is going to be physical changes versus chemical changes review video 21. So to just compare a physical change versus a chemical change, in a physical change, that change is not going to alter the molecular makeup of the substance experiencing the change, versus in a chemical change, that change is absolutely going to alter the molecular makeup of that substance. Another term for chemical changes is a chemical reaction. So any reaction that is going to alter the chemical makeup of a substance would qualify as a chemical change. Physical changes, on the whole, they tend to be reversible, whereas in chemical changes, they don't tend to be reversible as often, though there are absolutely examples of physical changes that are not reversible and chemical changes that are, which we'll explore in a second. Physical changes, a very popular example of a physical change is going to be a phase change. So melting, boiling, sublimation, freezing, condensation, anything that qualifies as a phase change is going to be a physical change. But in terms of a chemical change or a chemical reaction, there's so many different types of chemical reactions. And so we just have some indicators that will clue you in that a chemical reaction is taking place. So we could have color changing, we could have temperature changing, we could have an odor or a smell being produced, we could have gas bubbles being formed, or we could have a precipitate being formed. And a precipitate is another word for a solid substance being formed. Once again, physical changes usually are reversible, but not always. So examples of non-reversible physical changes would be chopping wood or shattering glass, because once you do that, you can't really put the wood back together and you can't put the glass back together, but you have not at all altered the chemical makeup of the wood by chopping it in half. The wood molecules are still wood molecules. The glass molecules are still glass molecules. It's just that you've broken the larger structure apart. Conversely, though reactions don't tend to always be reversible, some of them are. And reversible reactions we call equilibrium reactions, and you'll know you're looking at a reversible reaction if you see a double-pronged arrow like this, whereas most chemical reactions have a single direction arrow like that. So again, this one is going to be a reversible chemical reaction or equilibrium. And these diagrams just kind of represent a couple of examples of physical changes versus chemical changes for you. If you have any issues understanding the difference between physical changes and chemical changes, please talk to me in class.